Hello everyone, you're welcome to my channel. So in today's video we want to look at introduction to pandas. So we are in the Jupyter Notebook, and I'm going to create a new Python 3 notebook. Okay, so this is the new notebook. So when we talk about Python Pandas, Pandas is actually a tool in Python that enables you to carry out data analysis. It has methods, it has tools that can help you to manipulate data and help you to get results from data. So in today's class, I want to give you an introduction to Python Pandas, and this video is for those who are beginning, and also if you are advanced you can find some useful knowledge from it. So before we start, I want to show you the data set that we'll be using. So this is the car sales data, and it basically have 5 columns: the brand, the color, the odometer, the doors, and the price. So what you need to remember about this is that this is a row. Okay, this is a row, and this row is called row 1. This is row 2, row 3, then this is row 11. And then this is a column. Brand is a column, color is a column, odometer is a column, door is a column, and price is also a column. Now, any part of the data set that is having this rectangular box is the active cell. Okay, and then in Python Pandas there's what we call axis. As we get along, you find certain instances where we are going to be using axis equals. So whenever you see axis equal 1, we are referring to columns, and then when we say axis equals 0, we are referring to rows. Okay, please take note. When we say axis equal 1, we are referring to columns, and then when we say axis equals 0, we are referring to rows. Okay, so we'll now go to our Jupyter Notebook. Now the first thing we want to see is we want to create a series. Okay, so there are 2 data types in Python. Basically two main data types. Okay, 2 main data types. Okay, yeah, in Python Pandas. Now the first one is what we call a series. Okay, and series is actually a one-dimensional data. A one-dimensional data. So what that means is that if, let's say, we want to create a data set, a one-dimensional data set called car brand. Okay, so we say car underscore brand will be equals to. So before this, I'm supposed to import useful tools for our work. So this will be importing useful tools for projects. And the first one we'll import is import pandas as PD. So what that means is anywhere we call forth pandas, it should be represented as PD. So I'll run this. To run it, I'll click on Shift and Enter. Okay, so that has been settled. So we'll continue. Car brand equals PD dot read underscore CSV. No, please. PD dot read dot series, because we are creating a series data. Okay, and remember we are talking about a one-dimensional data. So this brand will just get 3 brands of car. That is Honda. Then the next one should be BMW. Then we have Hyundai. Okay, these are amazing cars. So we want to see the car brand. So if we run this Shift plus Enter, we'll run the cell and opens a new cell. Okay, so you can see now this is PD.series, just one dimension. Okay, it's having only just one column, and that column what you can find here under BMW and Hyundai. And you also notice something here called the D type, which is an object. We are going to get to that in a minute. So we want to open up another series, and then we'll call the series car color. Okay, so we'll say creating a new series called car color. Okay, so now let's say this will be car underscore color. So this will equal to PD dot series. Okay, and then we want to name this we want to give this first should be blue. Let's say the next is red. Okay, and then we have white. So let's read this data frame. Let's read the series, please. Let's read the series. So we'll call this car underscore color. Shift and Enter. Okay, so you can see this is how you can create series in Python Pandas. So you give the series name, then you call for the function pd.series, open brackets. Okay, then you give this the square bracket. So whenever you have the square bracket this way, you are actually putting the values. Okay, you are putting the values as a list. You are putting them as a list. So you put in the value in which are strings. Okay, blue is in strings, red is in strings, white is in strings, and then you put them as a list. So when you run this and then you read the series, you are going to find the output to be blue, red, and white. Okay, so we want to continue. The next thing we want to see is how to create another data type. So just as I said earlier, we have 2 main data types. One is series. Now the second one is called a data frame. So say creating a data frame. So there are 2 ways of creating a data frame also. So this will be the method 1. Now the first way is creating it from a series. Okay, you create it from a series. So this series that we've made here, or that we've created here, we want to create a data frame from a series. Now, a data frame is actually multiple columns, okay, or you can say it's two-dimensional. So a data frame is two-dimensional, meaning it has a row and it also has a column. That is what we mean by two-dimensional. Now, the method one will say is cars equals pd.dataframe. That is the function DataFrame. Okay, so we'll put this in dictionary format. Then we'll say car brand, car underscore brand will be the car brand which we've just created, the series. And then we also need the color to be the car color which we've just created. Okay, so let me explain this so that you get it clear. This car brand here is the car brand that we've just created as a series, and then the car color is also the car color that we've just created as a series. Okay, so we are now saying cars, which is the data frame, equals pd.dataframe, which is the function, and then we are passing all of them as a dictionary. Okay, so in this dictionary now, the column will be car brand, one column will be car brand, and the other column will be color. So let's get to read this. Read the data frame. So we'll say cars. We'll call the data sets. So can you see? So this is car brand, and then this is what color. So Honda, which is a brand, is having blue color, and then BMW, which is a brand, is having red color. Hyundai is having the white color. So you can see this is how you create a data frame. Data frame are two-dimensional. Okay, they are two-dimensional. You have the column, okay, car brand column, color column, and then you have the row. Okay, so 0 is a row 0, row 1, and row 2. So the next thing we want to see is the second method of creating a data frame. So we can name this, let's say car underscore 2. Okay, so this car underscore 2, we want to write out the data directly on the Jupyter Notebook. Okay, we are not creating it from a series this time around. So this will be, we'll put this as a dictionary once again. So what will be the column name? So we'll call this to be car brand. Okay, and then we need what will be the data sets. I mean the data within this column. So pass that in as a list. So we'll say under. Then we'll have BMW as a string, BMW. Then we also have Toyota. Okay, so this is in a list format. And then the next is the car color. Okay, the car color. So the car color, we also pass that as a list. And then let's say this is green. We have another one which is white. Then we also have black. Okay, so now this is second method, car brand, car color. And then when we read this, reading the data frame once again. So let's see, car underscore 2. Shift and enter. Wow. So you can see this is car brand and then this is car color. So these are the two ways you can be able to create a data frame in Jupyter Notebook. Now we want to go into the data set, which is the car data I've just shown you, which we are going to use. Let's see how we can be able to import this data into the Jupyter Notebook. Now the thing we are going to do here is we'll type this as a comment, import the data or the data set here. So in this case, we are going to call the new data frame, let's say car sales here, equals pd.read. Okay, so we are using the pd.read underscore csv. So we are using the read underscore csv function, okay, to actually read the data. Now we are using the read underscore csv because when we come to the folder where the file is located, you discover that the file is actually having the .csv. Okay, so the extension of this data set is in .csv. That is why we are using the read underscore csv. So I'm going to copy this out, Ctrl C, and I'll come to paste it as a string, Ctrl V. Can you see that? So this is how you do that. This is how you do that. And I'm going to create a separate video on how to import data even when the data is not in the same folder or in the same location as the Jupyter Notebook. Okay, so there are two ways. This I just copied and pasted. Also, you can use the autocomplete. Let's say I start typing and then I write car, and I put sales. Okay, I can put in the tab. Okay, once I press the tab key, all the options show. So I can click, because I need the first option, I'll click on the first option. So you can see that. So that is another way of importing the data set. Now we want to see what our data set looks like. So we'll read the data sets. So this will be car underscore sales. So let's see. Wow. So this is our data set. So just as I explained earlier, you have the brand, you have color, another column called the odometer, which is in kilometer. You have the door, and also the price of the individual cars. So the door is simply the number of doors of each car. There are no, I don't think there is any door that, I don't think there's any car that has 3 doors. So, but you know, this is a use case. So we have successfully imported the data sets. Now the next thing we want to do is we want to see how we can be able to export the data set. Let's say after working and manipulating and analyzing, and then we now want to export. How then can we export? So we'll say this is exporting the data set. So we'll use the to CSV. Okay, so now the name here is car sales. So I'll write car underscore sales dot to underscore CSV. Now to import, you use the read CSV. To export, you use the to CSV. Okay, So then you pass in the name that you want it to bear. Okay, that is the name of the file. So I want this to be car underscore sales, and because this is a tutorial, so I'll call this car sales tutorial, and then I'll give the extension .csv. Okay, so this file will be stored in the same destination as the Jupyter Notebook that I am currently working with, okay, in the same folder. So if, let's say, I want to specify a different folder, I will have to get the file path or the folder path of that particular folder and then fix it in here. So directly this file will go to that folder, but as it is now, it will go to the same folder as this Jupyter Notebook. So I'm going to run this, shift and enter. So car sales tutorial. So let's go to our folder and see if there is any file called car sales underscore tutorials. So let's see. So can you see that? So this is car sales underscore tutorial.csv. Wow. So you can see that we've successfully exported the file. Okay, we've successfully exported the file. So let's check out something very, very important, because whenever you export a data set, there are changes that are made to that data. So let's go further to say we want to still read the exported data sets. Okay, so this will be let's call this car still underscore sales 2 equals pd dot read underscore let's put this as car underscore sales. We press our tab key, it has auto completed it, and then we'll read this. So we are reading car underscore sales 2. Let's see, pd.read underscore, okay, csv, shift and enter. Wow, so can you see? So there is an unnamed column here. Okay, there is an unnamed column here, and this is different from the original data set. So you see that an index has been added aside the conventional index which is already available on the data set. So how can we rectify this challenge? Okay, so in the process of saving your data set, or in the process of exporting, there is a function called the index. Okay, there's a function called what? The index. So we'll call this index equals false. Okay, we don't want it to have that, so we'll press shift and enter. So that is it. So let's go forth and read this again, shift and enter. Good. So you can see the unnamed column is no longer there. So that is how you can be able to rightly export your data set. So the next aspect we want to see is describe. I want to see how to describe a data set. So describe data. Now I'll put this as a markdown. So I'll say escape and M, and then shift and enter. Okay, so that is how you create a markdown. Now we want to check out for what we call attributes. Okay, we want to check out for attributes. So we are still going to be using the car sales. Okay, so we want to see the data types of each column in the car sales. So we'll use the D type attributes. Okay, D types attributes. So shift and enter. Beautiful. So you can see the brand is having the data type object, color is object, odometer is an integer, doors is an integer, price is also object. So this just gives you the attributes of this data. And when we talk about attributes are quite different from functions. Okay, so functions are usually having the brackets behind them. So for instance, we just used pd.read underscore csv. Okay, so this is a function. So any write-up you see where it is having a bracket, having opening and closing bracket, please, that is a function. And then the ones that don't have a bracket is called attributes. So I'll need you to take note of it. So we want to check for the column names. We want to check for the column names. So of course you can do that. This is still an attribute. Car sales dot columns. Shift and enter. So all the column names. This is very, very important when you are dealing with a very large data set. You would want to see them individually. Okay, so in this case it may look as though it's very simple, but when you are dealing with a very, very large data set, that the columns are very large, very much, so you need to be able to know them. And yeah, so that is for the columns. So the next you check for is the index. It's very important to check for the index. And also this is an attribute, car sales dot index. So the index will return the start of the index and the end of the index and the differences, okay, between one index and another. So if let's say you see the start is what, 0, right? And then between 0 and 1 the difference is 1. That is why you see here the step equals 1, and then the stop is definitely 10. In as much as it is showing 9 here, what this is saying is that there are 10 columns. Okay, there are 10 rows, please. There are 10 rows of data within the data set. So now the next thing we want to see is we want to describe the numeric column. Describe the numeric columns. Okay, so in describing the numeric columns, this will be a function, car sales dot describe. Okay, so you can see, run this, shift and enter. So this gives you a statistical measurement, okay, of the numeric columns only. Okay, so this is car sales, which is the data, and then when I run the describe function, it only gives me for 2 integer columns, okay, which are the odometers and the doors. So you can see they are just 10 counts. The individual mean, you can find them here. Then the 75th percentile, 50th percentile, 25th percentile, the minimum value and the maximum value across each columns. So this just gives you the statistical breakdown of the numeric columns in the data set. So now we want to gather information. Okay, we want to get information about the data set. Information about the data set. Okay, so in getting the information about the data, this would also be a function, okay, and that function is .info. .info, it gives you information about the data set. So you can see that the range index is 10, just as you've known, 10 entries, and then it is 0 to 9. And you know, the info is very, very much powerful, and it gives you everything, both the D types and the columns and the index. Okay, so everything just comes up. And so you can see these are the columns, just as I said. You can see the number, which is 10. All of them are non-null. That means they all include values. There is no empty record. And then these are all the data types. So the memory usage you can also find there. Very, very low memory. So that is the brief information about this data set. And you can find all this very important when you are working with Python Pandas. Okay, now we want to see the numeric columns this time around. We want to check out some of the things we can carry out in the numeric column. So the first thing we want to do is to get the sum. Okay, the sum of items in the numeric columns. So what do we see here? So since we have two numeric columns, we are just going to highlight them, and then this will be car sales. We'll put this as a list, okay, in double square brackets. Now whenever you are highlighting multiple columns, it's good to put them in double square brackets. Okay, so then we need the doors, and then we say this is dot sum. Okay, so this dot sum is also a function, so it gives you the sum of the values within that particular column, or those particular column, as in this case. So say this shift and enter, so you can see the sum of values in odometer. This is it. And then the sum of values in the doors column. This is it. So let's check out for this mean. The mean of items in the numeric columns. It's good to always do well to type out your codes. It's good to type them out. It's very, very important. It helps you to understand what you are doing properly. So this is odometer, and then this will be in kilometer, of course, and then we also have the doors. Okay, so this will be dot mean. So we are using the mean function. Okay, so I've told the function has the curved brackets. So this is shift and enter. Okay, so you can see the mean. This is the mean for the odometer, and then also this is the mean for the doors. So we want to check out also the length of the data frame. The length, yes, it's very, very important for you to know the length of the data frame or the data set, as the case may be. So in this case, we are going to be using the len function. Okay, len, L-E-N, and then we pass in the data sets, car underscore sales, and then we run this. So there are just 10 rows of data within these data sets. So we are going to come back for the part 2 of this video, and when we come back, we'll look at how to view and select data, also how to manipulate data and see some levels of visuals we can be able to create from this data. So I'll see you in the part 2. You're welcome back to part 2 of the series Introduction to Python Pandas. So in the last video, we looked at several key points, and we saw how to import pandas also saw the two main data types in Python Pandas. We've seen the series and the data frame. We also saw how to import the data sets and also to export, to read. And then we've seen the differences between the attributes and the function. And then we saw also the description of the numeric columns, the information concerning the data sets, how to apply the sum and mean function to numeric columns, and finally the length of the data set. So in this video we are moving ahead. We'll go into viewing and selecting data. So we'll use this escape M and then we use shift enter. So the first thing we want to do here is to view the top records. Okay, top records. So in viewing the top records, we are going to call out the data set, which is or the data frame, which is car sales dot head. Shift and enter. So this gives us the top records. So as we know, there are 10 rows of data in this particular data frame. So when you use the .head function, it will give you the top 5 records. You can also specify. So we want to specify the number of top records. So that will be car sales dot head. Then we need the top 7. So I'll run this. So you can see this is the top 7. So that is how you can get the top records and specifying the number of the top records. Now I want to see the bottom records. Viewing the bottom records. So we'll use a function called tail. So this gives us the last 5 records within the data set. Also, you can specify the number of records at the bottom. Okay, so this will be car underscore sales dot tail. And then we need the 3 last row of data within the data set. So that is how you can be able to view the top and the bottom records. Now what about if we want to view a particular record? We want to select a particular record. That is where you have what we call the lock dot lock and dot ilock function. Okay, so now .lock and .ilock function, they are very important. Okay, whenever you want to identify a particular record within the data set or a particular group of record within the data set. Now in explaining these terms, I'm going to create a new data frame. Okay, not a data frame, please, a new series that I'll call animals. So I'll call this animals equals pd.series. Okay, so I'll call this cats, first to be cat, bird, snake, panda, then we have dog. Okay, now in creating this particular series, I can choose to give it an index, and that index I'll be specifying. Okay, so the index is a parameter within the series function. So I'll specify it, and then I want the first row to have the index 2, second row to have the index 3, third row to have the index 8, and then you have 9 and also 3. Okay, so let me read this. Read this series. So I'll call this animals, shift and enter. So you can see this. So this is a series, and you have cat, bird, snake, panda, dogs, and these are the indexes. Okay, so I specifically assign this index to each of the record. Now, what can we see here? Now, let's say I want to get the third row. Okay, the third row. Now, one thing you need to know is that .lock refers to the position, refers to the index, please. Okay, .lock refers to the index. So that means I can come here and I'll say animals .lock. It stands for locate. Okay, .lock 3. So if I call animal.log 3, shift and enter. Okay, let's see the error, key error. Okay, no axis name 3, 4. Okay, so I'm going to remove this, shift and enter. Good. So you can see .log refers to the index. Now this is the any record of data that has 3 as the index is given as the result. So you can see bird has index 3 and also dog has index 3. So whenever you use .log, kindly take note that you are referring to the index of that particular record. Now let's look at the car sale. So let's call forth car sale.log. Okay, 3. But before that, I want to call forth the record. So this is 0, is 0, 1, 2, 3. So this will be 1, 2, 3. So the third record is supposed to be Toyota. So let's see. We are calling this forth. Okay, let's see. So based on the index, sorry, I made a mistake in the other statements. So based on this index, okay, actually the third record is Toyota, but then the index is by index BMW is the third record. Okay, by index BMW is the third record, but conventionally the third is supposed to be Toyota. So locate the third record, I mean the index having 3, the index having 3, and you can see this is BMW, black, you know, all the attributes of the car. So that is how you can be able to use the lock. Now the iLock refers to the position. Okay, it refers to the position. Now what do we see here? Let's go and check out the animals series. So animal series, so this will be iLock. Then we need a position 3. if I run this, so this is Panda. So this is 0, 1, 2, and 3. Can you see that? That is why it gave us the result Panda. So iLog gives you the result, the position as the result, while lock gives you the index as the result. Now let's see that of the car sales. Car underscore sales. Okay, so the car underscore sales dot iLog 3. Okay, so it returns BMW as the result for the position 3. So also, one thing you need to know is that iLog can be used similarly to slicing. Okay, slicing, which is a characteristics in Python string and Python list too. So, but then it does not include the index, the ending index. That is for the iLog. It does not include the ending index. Now, let me show you what I mean. So let's take note of that. To say that iLog refers is same as slicing in Python, but doesn't include the ending index. So now in this example, I'm going to use the animals. Okay, then I'm going to say dot iLog, and then I'll put the colon 3. So what I mean by this is that from the beginning to the third record. Okay, so if I run this now, just watch. So this is 1, this is 0, please. This is 0, 1, and 2. So it won't include the index 3. Okay, it won't include the index 3. So now let's check out the car sales. Car sales.ilog. Also down to 3. Let's check this out. So you can see this is 0, 1, 2. So there is no 3. So it doesn't usually include the ending index. But then the lock includes the ending index. So let's say this car underscore sales dot lock. Okay, shift and enter. So you can see it includes the ending index 3, which we specified here. So that is how you can be able to use the iLog and the lock. The key difference, I take it again, the dot lock refers to the index. So in this particular animal series, we changed or we specified the index, and when we call forth that particular index, it is the index it is the data within or on that index, the data on that index that was shown as the result. And then we also tried that for the car sales, the data within that index that is shown as the result. Now for the iLog, it refers to the position. Okay, so the position regardless of the index. Okay, so whatever value or whatever data that is on that position is what will be shown as the result. And then also the difference is that in as much as the both of them, they are slicing in Python, the iLog doesn't include the ending index, just as we've seen here. Okay, this is 0, 1, 2, while the log has the ending index, which is 0, 1, 2, 3. Now we want to see how we can be able to view columns. View columns. Now, there are two methods that we can use here. Method 1. So using method 1, you can say this is car underscore sales. Then you put this as brands. Okay, before that, let's see the car sales. Okay, so we have brand. So we want to see this particular column. This is shift and enter. So you can see this is for the column. Now there's another method again, which I will call method 2. So I'll call this cars underscore sales dots brand. Okay, so they will still give you the same result. So this one is having the square brackets, and also the column is in is represented as a string. Okay, the column is represented as a string. Now in this case, there is no square brackets and there is no string, so you use the dot. So but the key difference between these two is that if you are having a column name that has space, you can't use this method 2. You cannot use method 2. For instance, we have a column called odometer, which is having a space and then the column, right? So let's check it. So this is odometer having a space and the column. So let's say this is AM. Can you see it says okay, car sales not, shift and enter. Can you see attributes error? It say has no attributes odometer. So you see, so that is the error you are going to find. So anytime you are working with a column name that has space, it is good to use method 1. So strike this out. So now what do we see again? We want to see how to select a portion of the data with specific filters. Okay, selecting portion of data with specific filters. Now in this case, I want to get the brand of cars that is named Toyota. Okay, brand of car named Toyota. Please, you forgive me for some typographical errors. Okay, so in this case, I'm going to say car underscore sales, and then I'll put this again, car underscore sales. I'll call forth the column name, which is what, brand. Okay, because I want to select only Toyota from the brand. So this will be, I want the brand name called Toyota. Okay, so simply what I'm saying here is this is the column name, and then show me the result of this particular brand name, okay, which is equal to Toyota from this data frame, which is the car sales. Okay, that is what this line of code means. So if I run this now, so you can see Toyota, every brand here is Toyota with their different attributes or their different make. So let's check out another one. So we want to get, let's say, the cars whose odometer we want to get the cars whose odometer is greater than 100,000. Okay, that's it. So you go again, car underscore sales, car underscore sales. So this time around we are using odometer. Odometer is in kilometer. Then we say is greater than 100,000. Okay, so if we run this, shift and enter, so you can see Toyota and Nissan. So these cars have the odometer greater than 100,000. So this is how you can be able to filter specific records from the data set. So the next thing I want to see is how to compare two columns. Comparing two columns. So there are two methods, or there are two ways of comparing two columns. You can use the cross tab. Okay, the cross tab function. You can use the cross tab function, and what are we comparing here? We are comparing the brand. Okay, let's see the brand against the color. Car sales, then we'll call this the color. Let me see how it is here. Okay, color. So we want to compare these two columns together. Car sales brand and also car sales column. If I run this now, so you can see. So when you look at this, the number of BMWs that has black color is 1. The number of Honda that has blue color is 2. And the Honda that has red color is 1. The number of Nissan cars that has white color is 2. And then the number of Toyota vehicles that has that has blue color is 1, green is 1, and white 2. Okay, so that is how you can be able to compare and to contrast between two columns. Now also you can compare and contrast using the group by. Okay, so in this case we are comparing columns in the context of another column, or of another column, or columns, okay, of other columns, as the case may be. So in this case we want to compare within the car sales. We'll use the group by function, group by, to compare the bread and the brand, please. Okay, and then we are comparing it in terms of the mean of car underscore sales, the mean of the odometer. Odometer and the DOS. So the odometer, don't forget, is in kilometer. So what we are saying is we want to group the brand of the car based on the mean of these two numeric columns. So remember, we are comparing column or columns in the context of another column. So when we run this, let's see. So for the brand BMW, this is the mean of the odometer, and this is the mean of the doors. And then under, this is the mean, and this is the mean value of the door. So individually, according to the unique values in the brand. Okay, so we can get also we can group also the colors based on so let's say colors based on the odometer. Okay, and the doors. So shift and enter. Let's see what we have here. Oh, key error. Okay, so let's see colors. So what do we have? Or is it color? Okay, it's just color. So this shift and enter. Okay, so that is how you can be able to compare and to contrast. Now there is a particular column we've not looked at if you've been following, and that is the price column. Yes, the price column. You can see this dollar sign directly in front of it. So let's go and visit the price column. Yes, so I'll type this here. Visit the price column. Okay, so what do we want to see? Let's see properly the the price column. So we say price, car sales. Okay, this is sales. So this is the price column, and we see that the data type is objects. So when we talk about objects is simply the base data type of all values in Python. Okay, is the base. Unless you specify that, okay, this is an integer, this is a string, this is a class, this is a list. Unless you specify, if you don't specify, Python automatically classify that particular column to an object. Okay, so that is the meaning of D type equals object. So now let's convert the data type of price column into an integer. Okay, so we want to convert the data type into an integer. Okay, so in converting this into an integer, we'll say underscore sales, and then this is the price. So we need this to be equal to car underscore sales, also the price. So we are going to convert this into a string, and then we replace. As we replace, we are replacing everything within, that is everything, okay, that has to do with the dollar first, and then aside the dollar, the comma, and then aside the comma, let me confirm this. Okay, then you have the full stop. Okay, so those are the key things that are that's actually characterize the price column. So you can see the dollar, you can see the comma, there's also the full stop. It's supposed to have a full stop in the original data set. There is the full stop. Okay, so let's continue. So since there is no full stop in this case, we'll just leave that for now. So, and then what do we have next? We want it to return an empty string for us, and then Python will convert the data type into an int. Okay, so let's run this and let's see. Okay, so we can see that it has been done. So let's try to see the price. Beautiful. So you can see, so it's no longer object again, it is now integer, and then there's no $sign, there's no comma. So this is how you can be able to convert a data type from object into an integer. So let's go into creating some visuals. Yeah, creating some visuals with the data. Good. So the first one we want to see is the odometer. Let's take a look at the odometer. So this is car underscore sales. Okay, we need odometer. Okay, so we want to plot this dot plot. Okay, we'll call this dot plot. Let's see. Oh, that's very beautiful. So this is the graph showing the spread of odometer. So you can see that this is the value as it is increasing. Okay, this is the row. 0 to 8, 9, and yes, 0 to 9. This is the row, and then these are the values. So then let's check another column, which is the price. Let's check out the price dot plots. So this is the function. So you can also see the price. So sometimes you may try out these functions and it will not give you any results. Like you would not see any graph or any visual. You just come to where you import the useful tool, and then you type import matplotlib dot pyplot as plt. Okay, so when you type this and you run, then you can now go back and run the visuals again. Okay, so then we want to check out the histogram. Yes, the histogram. Histogram is actually a very good tool that shows the distribution of data. Okay, so let's see visualizing histogram. So what are we visualizing in this case? We want to visualize the odometer once again. So the car sales. So we need the odometer in kilometer. Okay, dots ist. That's the function. So can you see? So this is very, very good. Now when you look at the histogram, you see these compacted colors, it shows that these are the spread. Okay, so majority of the data is spread between less than 25,000 to more than 100,000 at this point. So obviously these two values are outliers. Okay, so that is how you can be able to analyze histogram. That is how you can be able to analyze histogram. So the next key aspect, wow, it's been huge. So the next key aspect we'll look at is manipulating data. How we can manipulate data. So make this to be a markdown and then shift and enter. So let's see how we can be able to manipulate our data set. The first thing is to see how to reduce the case, okay, the alphabetic case of a particular column. So let's say we want to lower the case of the brand column. So now in this case, we'll say is car underscore sales. We'll call for the brand, so we can still use the dot brand. Okay, and then we'll say dot string, because you can only lower a string data type. Okay, so string dot lower function. We run that so you can see. So, but this has not been assigned. Okay, this has not been assigned because when you call forth this is control and okay. So can you see the Toyota is still having a capital letter T and the Honda is still having a capital letter H. So for you to make this to be permanent, you will now reassign it into the column. So this will be car sales, and then you call this brand, okay, equal to car sales dot brand string and lower. So when you run this now, so it is now there permanently. So let's check it out. Good. So can you see it now? So this is small letter, small letter, small letter. All true. So let's see how we can be able to work with the missing data. Now, prior to the start of this class, I'm supposed to show you a record that we have, which is a missing record. And just follow me, work with me. Let's see this together. So this is the car sales missing data. So this particular data set is having missing records. Okay, it's having missing records. So you can see the odometer is having quite a number of missing records, and even the price too is also having quite a number of missing records. So we want to import the missing records. So we'll say read the missing data. So we can find the missing data even within the folder. So you can see this car sales missing data.csv. So we'll come here, we'll call this car missing data equals pd.read underscore csv, open brackets, call this car missing. I'll press the tab key, autocomplete. Okay, there's no word like that, so I'll put this underscore missing. There's no word like that too. So let's go and continue. Let's say car sales tab. Okay, good. So you can see car sales missing data, and then I'll press enter. So let's call this forth car underscore missing data, shift and enter. So you can see, so usually missing data are represented by NaN. Okay, NaN. Honestly, I can't tell the full meaning, but I think it stands for null. something null. So so you can see those spaces we've seen in Excel. You can see they are now represented using N, A, N. So what are the things that we want to see in these missing records? So the first thing we want to undo, we want to handle the missing records. So we are going to be handling the missing records in the odometer column. Okay, so we want to handle it using the mean value. We want to handle it using the mean value. So we have to get the mean value first, right? So get the mean value. So we'll call this car underscore, let me see, the car missing underscore data. Okay, and then we get the odometer, which is in kilometer, dot mean, which is a function. Let's return this lesson. Okay, so we have seen the mean record. So let's go forward now and replace this mean record. So say replace the missing records with the mean value. So we are now replacing with the mean value. So this is car underscore missing data. Okay, so this is odometer, which is kilometer, dot fill now. So fill now is an option. Is a function that enables you to fill a particular column, okay, or to fill empty records within a particular column. So we are going to be filling with the car missing data, and this will be odometer in kilometer. So we are filling it using the mean function. Okay, so let's see this. Shift and enter. Good. So we have filled it in already. So you can see all these options here are the mean. So now, does it mean that this code, this line of code that we've run here, has it been enacted? Has it been assigned into the original missing data? Let's go and check it out. So this is car. I'll hold down my control and then I'll click here. So let's check it out. Shift and enter. Wow, we are still having missing records here, but here it showed it has been filled. What then is the problem? How can we be able to resolve this challenge? How can we make it to become the main data within that particular column? There is a way out, and that is where the in place come in. Okay, the in place attribute. So because of time, I'm going to just copy this and then I'll paste it here. It's okay. So now dot fill now. Now the next thing I'm going to do is to put a comma and then I'll say in place. So what in place does is in place helps you to reassign. Okay, in place helps you to reassign the value or the corrected value into the main data. You understand? It makes it to become permanent. So there are two methods you can reassign. I think I showed us earlier. So this way you can reassign car brand, car sales, brand equals. So you use the equal to reassign. So we are now reassigning this particular function, this particular code or changes into the brand. Okay, this is one way, and then this is also another way using the in place. So if I do shift and enter, so let me go forth and confirm. This is control. I'll hold down my control. So let's confirm this. Wow, you can see. So there are no more NaNs again. So it has all been filled here. That's good. So what can we do to the rest of the car missing data? What can we do? Okay, so the thing we can do, like you see this, see this. Okay, we have to delete. Okay, we have to delete. So in deleting, we'll use the drop function. So the drop NA function, please. Car missing underscore data, and then we'll see dot drop NA from this. So it has been dropped. Okay, it has been dropped. Now let's create a new file using this dropped file. Dropped data set. Let's create a new file with it. So I'll call this I'll say car missing data dot drop now. Okay, now I'll call this car missing. Let me create a new data frame. Car missing dropped. Okay, so this will be equal to car underscore missing underscore data dot drop NA. So I'm now assigning this dropped record into a new data frame called car missing dropped. Shift and enter. So now I want to export the missing, I want to export the dropped data frame into a new file. So I'll call on the data frame car missing dropped dot to underscore CSV. Okay, I want to give this new file to be called car underscore missing underscore dropped dot CSV. Okay, car missing underscore dropped dot CSV. Shift and enter. So the file has been created, car missing underscore drop dot CSV. Let's go forth and check it. Car missing underscore drop dot CSV. So you can see this. So this is the file that we've just exported. So now the next thing I want to see is how to create a column within a data frame. How to create new column within a data frame. So there are up to 4 ways you can do that. Creating a column within the data frame. So the first way you can create is create from a series. Okay, so in this case let's assume we want to create a series called seats. Okay, we want to get the number of seats. Okay, so this is pd.series, and then we'll give this number of seats such as 5, 5, 5, 5. We created 5 records of it. So let's see the seats. Shift and enter. So you can see, so this is it. Now let's insert the series into the data frame. So we are going to continue using the car sales. Sorry, So we are going to continue using the car sales. So this will be car underscore sales. And then we want to assign this a new column called, let me see. We have the, okay, seats. So seats will be equal to seats. Okay, so this seats that is here, this is it. And then we are assigning it into this new column. Shift and enter. So you can see. So let's go and check this out. Shift and enter. Wow, so we still have missing records. So how can we resolve that? So we can resolve that by imputing the values. Okay, we can resolve it by what? Imputing the values. So we are going to come here and then we'll say car sales seats we are filling. Okay, so I'll give this a comment, filling the missing records with the value 5. Okay, fill now, and then we need 5. Okay, of course, if I am to run this code, it would show me the result here, but it will not be reflected within the main file. That is within the main data frame. And I want to guess you know the reason. It is because of the attributes in place. Okay, so the in place must be true. Shift and enter. So when we go and call for car underscore sales, let's see it. So you can see seats, all the values are now complete. So that is how you see the importance of in place too. So let's go. The second method is using the lists. Okay, creating a column from a list. So we are going to create a new list called fuel economy, and then we'll put these values, let's say 3.4, 7.3, 5.6, 2.3, 5.2, 1.3. It is 1, 2, 3, 4, 5, 6. Okay, 7, 9, and 10. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we have 3.8. Okay, so please, I want to encourage you to go and watch my video on how to create column within a data frame. Okay, how to create column in a data frame, how to create column in a data frame. I explained extensively on this. Okay, especially these lists. There are some explanation I give there that I did not emphasize within this particular video, so do well to watch it. So I'm going to insert the list into a new column called fuel economy. So let me see what we have here. So this will be car underscore sale, and then this will be fuel economy. This is equal to fuel economy. Shift and enter. Let's see car sales. Okay, it's not defined. Okay, so car sales, good. So let's check out car sales once again. car underscore sales, shift and enter. So you can see, wow, beautiful. So let's want to create a column from another column. Yeah, I want to create a column from another column. So we are going to be manipulating, still on manipulation again. So we want to, in this case now, we want to multiply, or want to divide this odometer by 100. Okay, we'll divide this odometer by 100, and then we'll multiply it by the fuel economy. Okay, we'll multiply this by the fuel economy. So the main idea now is we are converting this odometer into the total fuel that is used, and we want that to be in liters. Okay, so because we want it to be in liters, we'll divide the odometer by 100. After dividing odometer by 100, then we'll multiply it by the fuel economy. That will give us the total liters that is used by each of these cars. Okay, so that is what we are going to do. So we are creating column from other columns. So this will be car underscore sales, and then we'll call this total fuel used. We want this to be in liters. Okay, this will be equal to, we'll say is car underscore equal to car underscore sales. So we want odometer which is in kilometer. We want it divided by 100 and multiplied by car underscore sales, which is fuel economy. Okay, so run this. So let's see the car sales. Shift and enter. Beautiful. So you can see, so this is total fuel that is used per liter. Just as I said, we converted this from odometer into what? Into liters. So what we did is odometer divided by 100, and then we multiplied it by the fuel economy. So that is how we got the total fuel that is used. So the last method of creating a column is creating column from a single value. Is this the last? I said there are four methods. This is one, I think. Okay, this is 1, 2, 3, okay, 4. Okay, there are actually 5, please, from a single value. So let's go. So we are calling this car underscore sales. We want to get the number of wheels. We want it to be equal to 4. And let's see the data. Car sales. Shift and enter. Beautiful. So number of wheels equals 4. So the last way of creating a column from, or creating with a Boolean value. Please, I want to encourage you to go and watch the video. Watch my video on how to create columns in DataFrame. I explain extensively on these concepts. So this will be passed road safety. So the Boolean value I want it to be assigned here is true. So let's see car underscore sales underscore sales. Okay, shift and enter. So the vehicle pass through safety is true. So the last aspect we want to look at in this series of introduction to Python Pandas or to Pandas data frame is sampling data. So we'll create this as a markdown. So we want to see how we can be able to sample data. So let's say you are working with a very large amount of data sets, and there are several times that, like, I mean large, talking about 500,000, 1 million, 1 million, 2 million records of data. In this case, we are just using 10. 10 is very, very small. So you would want to sample the data sets, okay? You want to work with a little amount of the data sets to get a picture of how the entire data set would look like. So in this case now, we want to shuffle the index, okay, of the data set using sample. So we want to shuffle. How can we shuffle? We'll call this car underscore sales. We'll use the dot sample function. So the dot sample function takes in a parameter called the frac. So when we say frac equals, let's say, 0.2. Okay, so let's run this, let's see. So you can see out of 10, 0.2 returns for us two records. So what that means is that this frac is like is a fraction, of course, is a fraction which is over 1. Okay, it is what, over 1. So any fraction between 0 and 1. So 1 is 100%. 0.5 means 50%. 0.2 means 20%. So if you are working with, let's say, 1 million records of data, and you want to use a sample of that data, okay, you can, if you say 0.1, that means 10% of 1 million, which is 100,000. You work with it. If you say 0.2, that means 200% of it. That is 200,000. Okay, that is 0.2 means that is 20%, meaning 200,000, right? Okay, so you specify the fraction of data that you want to sample, and of course you know that this is shuffling. So in this instance, 7 is an index, 2 is an index, so it has shuffled it. If I run this again, can you see 8 and 2? So the more as you keep on running, it will be shuffling the records, and also it will give you the 20% of the entire data set. So we want to assign these records now into a new data frame. We want to assign it into a new data frame. So I need the entire record, so I'll put this to be equal to 1, shift and enter. So you can see it has shuffled the index. 0 is no longer the first. So I want to assign it, so I'll call this car sales shuffled. Okay, so this will be equal to car underscore sales dot sample, and then this is frac equals 1. So let's run this. Okay, so that is, I want to see how the data frame is. Control and okay, so let's see what is there. Shift and enter. Okay, so this is 1. So you can see, so that is how you are able to assign it to a new data set. Now, what if you want to reset the values? Okay, you want to reset the index back to the normal way. Of course, there's a way to do that. You can do that using the .reset.index function. So we are going to come here and then we'll say car. Let me see this. Car reshuffled, control, and okay, car reshuffled, car sales dot reshuffled dot reset dot index. Okay, so what are we doing? We want to give it a parameter called drop. Drop will be equals to true. Okay, and then in place will be equals to true. Of course, you know that. So the in place is a parameter that is almost always in every function. So the in place equals true, the drop is equal true. So what it is dropping is that it is dropping any kind of changes that has happened in this particular data frame. Okay, it is dropping it. So shift and enter. Let's see. Data frame object has no attribute called reset. Okay, so let's see reset underscore index. Oh, beautiful. So that has been reset. Now let's go and check it out again. Car sales. Let's see. Oh, that's good. So you can see the index has been reset. So the final we want to see is how to apply lambda function. Apply lambda function to a data frame, and in this instance we want to convert odometer, which is in kilometer, into meters. Okay, so in doing that we'll say car underscore sales, and then we need odometer, which is in kilometer, to be equal to car underscore sales odometer dot apply. Okay, and then we'll call in the lambda function x to x, okay, divided by 1.6, and then okay, so we'll close this, we'll give this a space. So what this means is we are saying car sales odometer, which is in kilometer. Okay, I don't want this to be in kilometer. I think this should be in meters, right? Yes, because we are creating a new column. So this is odometer already. And then let me see. This is kilometer. This. Okay, so we are saying car sales odometer, which is in kilometer. We want the machine to apply this function called lambda. Okay, so lambda is an ambiguous function, okay, that you can use to perform a lot of calculations. And what we are literally saying is lambda, there is a variable which is x, and we want this x, we want it to reset this x to be equal to x divided by 1.6. So if you are converting from kilometers to miles, sorry, not meters, this is miles. Okay, if you are converting from kilometer to miles, you divide it by 1.6. Okay, so we are saying car sales odometer kilometer. Apply this lambda function on x, and this x, you now reset it to be equal to x divided by 1.6. Do you understand? So then I'll shift and enter. Then I call for the car sales. Let's see what we have. Beautiful. So you can see. So this is 150,000, and then this is 93,000. So this is all we can take on the introduction to Python Pandas. So I hope you've been able to learn something new from this video, and I would be in the comment section to listen to your questions and to also assist you with whatever queries that you may have. And I would drop the file on my GitHub page. You can do well to, and also I will attach the link to the description of this video, so you can do well to click on the link to access this original file. So I'll see you in another video.